Jai Hind, my dear friends. Today I am going to start new topic in computer organization and architecture, and the name of topic is modes of I/O data transfer. Myself Akhilesh Verma, I am assistant professor in Department of Computer Science and Engineering. So let's start this topic, modes of I/O data transfer. There are various modes of transferring information between internal storage and external I/O devices, and these are programmed I/O, interrupt initiated I/O, and direct memory access. We know that the interface which is connected to the external environment of computing system or CPU is called as I/O interface. So this is the brief organization of I/O interface. I/O interface basically at one side is connected with the rest of the world, and at other side it is connected to the inside of the computer system. Usually we are connected to the bus of computing system. So there are buses like data bus, address line bus, and control line buses which are connected on the other side. So whatever data comes on this interface from the rest of the world, like we can have a keyboard, okay, or we can have a connected devices like audio or any capturing device like video input output devices are connected to this interface. So the IO module is basically act as a wall between the CPU and the rest of the world. So this IO module helps in hiding and showing the device properties to the CPU. So it is not always visible to the CPU, it is shown whenever it is required. And also at this point it supports multiple or single devices to be connected. So control of this is done through this IO interface, and CPU is not engaged there. So this IO interface basically removes CPU while some data being exchanged with the peripheral device with the IO interface, and whenever this IO interface is ready to send data to the bus inside the computer, then it will allow it to send data, and most of the time CPU is free from the input output exchange. So as we have told, there are three ways: programmed IO, interrupt driven IO, and direct memory access based IO. We will discuss it in detail in today's lecture, and these are called as modes of transfer of data with the input output interface. So let's begin with the first, the programmed IO. Now programmed IO is basically instructions that result into a writing of data, okay, through a program. So each data item transfer is initiated by instruction in the program. So from the name it is evident that whatever is being transferred with the IO interface, that is read or write, it is under the control of a instruction, and this instruction is part of a program, and that's why this particular IO data exchange is called as programmed IO. Now when it is under the program control, so data transferred to and from the CPU and the peripheral, okay, is under the program behavior. and that is why there is a constant monitoring required for the peripherals by the CPU. So, CPU is engaged, CPU is busy while it is transferring data through programmed I/O. So, let us see what are the steps that are performed during the programmed I/O step by step. First, CPU request I/O operation. Okay. Now, after the request has been received to the I/O interface, the I/O module performs operations to read or write the data with the peripheral devices like keyboard. Okay. Now, I/O modules in the third step sets the status bit, that is the I/O processor is ready, I/O interface is ready to send the data to the CPU. Now, this bit is periodically checked by CPU. So, in the fourth step, this status bit is periodically checked by CPU. So, basically CPU does not inform the I/O module does not inform to CPU directly. Okay. CPU monitors, or you simply say it polls the I/O interface again and again to know what is the status, whether the data is available or not. So, I/O module does not interrupt by CPU, means CPU is not told by the I/O module that data is available. Okay, it only sets the status bit, and this status bit is periodically checked by CPU. So, in this condition CPU may wait or come back later again and again. So, what will happen? Under programmed I/O, data transfer is very like a memory access, like we perform memory access by CPU. So, each device is given an unique identifier address, and the CPU command will look for that address to be read. So, CPU command contains an address identifier for which particular interface it has to read the data. Now, certainly as we have seen, okay, we are able to see that there is a disadvantage of programmed I/O. The problem with the programmed I/O is that the processor has to wait, okay, for long time for I/O module to be ready either for reception or transmission of data. In both cases, if the data is to be transferred to the interface, or you have to read data from the interface. The processor, while waiting, must repeatedly interrogate the status. So, this is a sort of polling that the processor performs on the status bit. Okay. So, the performance of entire system is severely degraded when we are doing a programmed I/O. Okay. And another thing, that for each byte we require 3 instructions as we do transfer of data with the memory. Okay. So, this will happen: read the status register, check the status of flag bit and branch to step 1. If not, go to step 3 and read the data register. So, that will be a for loop which is going recursively endlessly till the data is available. Okay. Now, in programmed I/O method, CPU stays in the program loop, that is very important, until the I/O indicates that it is ready for data transfer. This is a time consuming process because it keeps processor busy needlessly. This problem can be overcome. Okay. So, not always we require that CPU is busy for just copying data with the interface. So, this problem can be overcome with the help of another mode, that is called as interrupt initiated I/O. So, what will happen? Like we are doing earlier polling, now the interrupt is generated by the interface and the CPU knows that data is available. So, in this interface determines that the peripheral is ready for the data transfer and it generates an interrupt, and after interrupt is received by the CPU, okay, the CPU normally stops the current task, okay, and then it services the IO and transfer the data to the memory location, and after it has transferred data from IO interface to the memory location, it will return back to the previous processing task. Okay, so let us understand this interrupt driven IO processes. Okay, so the steps involved are: first, CPU issues a read command. Okay, now after the CPU issues a read command, IO module gets data from the peripheral while its CPU does other work. Okay, so after the step 1, that is read command, and the peripheral knows that there is a request for data from the IO interface. Okay, so CPU is not able to give data at the same time. What will CPU will do? CPU will work for another task or the same task which is given by the operating system. Now, meanwhile, the IO module interrupts the CPU when the data is available. Okay, so while CPU is engaged in other tasks, useful tasks, it will see the interrupt status and CPU requests the data from the IO interface. Okay, and then IO module transfer data to the location where it is needed, like it can be transferring to the main memory or any other IO interface. So, this graph shows the pictorial representation of the process. So, in the first step, the CPU sends a request to IO. Okay, so issue a read command to IO module. Okay, and after that it will do something else as per as operating system's requirement, performing the same process, or it may switch to the another process. So, the request has reached to IO device. Okay, now whenever data is ready, the CPU will be getting an interrupt signal. Okay, so IO unit sends a interrupt signal to the CPU unit. So, it will read the status of IO module and finds that data is ready and available. Okay, and if it is ready to transfer data, it will proceed to the next step, and if it does not have this status, it will give error condition that data is not ready, and accordingly the operating system will schedule some other task or it will go for the another request. Okay, now if it is ready, it will read the word from the IO interface registers, and the IO module will transfer data to the CPU. Okay, and when it is signaled to the CPU will signal the data transfer and it will go to the memory location somewhere. So, CPU will then send the data to memory. Okay, now this will be done byte by byte or the size of volume of data that is transferred in single unit. Okay, if the task is done, data is not available, okay, it will go to the next instruction that the CPU is executing, and if the task is not completed, it will again go to the first step and issue a read command to the IO module that the data is not still received, and the same cycle will goes on again and again. Now, we should note that the operating system plays a very important role, and it will ensure that this task is done, okay, after the process is interrupt, and it saves the context. Okay, so usually the context include the next PC, okay, that has to be saved, and plus few of the register contents that is in the CPU, which is a temporary data that is current instruction is executing, that has to be saved. So interrupt driven IO transfer, operating system plays a very important role while the interrupt is generated, so that the processor is utilized for some task other than the currently running process. So multiple programming is possible. So this is one another advantage of interrupt driven initiated IO is that multi programming is possible, multiple processes are running. By default, we can simply say that the main program and IO program are running one by one, but in case the main program is not running, we can schedule it to the another process through the operating system scheduling algorithm. Now, if there are multiple IO interfaces, so we need to prioritize the priority among the interrupt. So each interrupt line has a priority, and higher priority lines can interrupt lower priority lines, and if bus mastering, only current master can be interrupted. Okay, so multiple interrupts are also deal here depending upon the priority order. Now we have seen that programmed IO processor waits. So you can highlight this, the processor is waiting. So this can be seen that processor is not doing something else. Okay, so there is a problem in a programmed IO, that processor has to wait and it can't do until the IO operation has been done. Okay, so to relieve that processor, that it can be engaged for any other task. Okay, interrupt driven IO is being designed. So operating system plays a very important role. Whenever IO request is given to an interface, till it is being ready to serve the data, the processor is engaged somewhere in other process, okay, or the same process for doing the task if IO interface is not needed immediately. Okay, so these are the advantage of interrupt driven initiated IO with respect to programmed IO. Now if you see this interrupt driven initiated IO, there is a problem in case of multiple interrupts. So what will happen if there are multiple interrupts? The IO initiated using interrupt, okay, will busy the processor for the servicing of interrupt service routine. Okay, so if multiple interrupts come, okay, so we are basically engaged in servicing the interrupt. Secondly, this case is good when the word size or data size to be transferred are few bytes, because transferring few bytes will consume very few cycles. Okay, but what will happen if we have large volume of data to be transferred from IO interface to the CPU or the memory? Will this interrupt driven initiated IO will be perfect? No. Why? Because at the last step, since the write operation is not complete because of the large size, this loop will go on for large amount of time. Okay, so the processor is unnecessarily engaged to serve the interrupt service routine till the large volume of data is being served. In this case, it is creating a problem which is much bigger than the programmed IO. Okay, so what should we do? So for to overcome this problem in interrupt driven IO for the large data to be transferred, another technique that is called as direct memory access, that is DMA, which is a very good technique for large volume of data to be transferred from the IO to the inside the CPU buses. So how the DMA works? DMA removes CPU from the path of letting peripheral device manage memory bus directly. Okay, and this will improve the speed of transfer, and this technique is known as DMA, direct memory access. Fine. Why? Because interrupt has to be seen and served regularly. So, if we remove the CPU from the path of peripheral device, the data is directly copied to the IO interface to the memory. Okay. So, in this the interface transfer data to and from the memory through memory bus directly. A DMA controller manages this transfer of data between the peripheral and the memory unit. Okay. So, who takes the advantage of these DMA based IO transfer? We have seen there are few IO controllers, like we connect various disk drives. Okay. We have seen that SCSI, okay, are interfaces. We also know there is a graphic cards which needs a IO interfacing. We see that there are network cards. Nowadays the Wi-Fi module chip is also there. Okay. We see that many times we want to record a high quality sound, or we want to capture a high quality video. So, in that case the IO interface generates a large volume of data, and in this case the volume of data transfer is large. So, it cannot be served through interrupt controlled data transfer. Why? Because for every data transfer you have to look for the interrupt, that yes, data is available, and for a large amount of data like in megabytes or gigabytes, what will happen? The interrupt will be raised again and again, and the data will be transferred byte by byte, and you can assume think very simply that transferring data in terms of megabytes or gigabytes byte by byte under the supervision of CPU through interrupt initiated IO data transfer will take lots of time for the CPU, and the CPU is not utilized for the another important task like arithmetic and logic operations. So, this will engage the processor. So, these are the input devices or interfaces which basically has the large volume of information. Okay. So, in DMA CPU would initiate the transfer, that it will start, and then it will do other operations while the transfer is in progress, and receive a interrupt from the DMA controller when the transfer has been completed. Okay. So, now the DMA is acting as a lieutenant to the CPU, which is taking a charge from the CPU that they will engage in transferring of data. When data transfer is completed, then it will transfer control to the CPU. Now, if we see the step and comparison, interrupt driven and the programmed IO requires active CPU involvement. So, this is the problem. We can see that, and transfer is limited by processor to test and serve the device. Okay, it has to recursively test and serve the IO interface. So, basically CPU is tied as a manager for IO transfer. Okay. So, additional module that we are saying, that is a lieutenant to the CPU, okay, can be added to the bus, and that is called as DMA, and DMA act as a controller to takes over the CPU for IO data exchange. So, DMA module must use bus only when the processor does not need it. Okay. So, the higher priority over the DMA is processor. Whenever processor require the CPU bus, it will be used by CPU, and when it is not used by the DMA, not used by processor, then DMA will use that CPU bus. So, it forces the processor to suspend the operation temporarily. This technique is called as cycle stealing. Okay. So, for the time being, processor is stopped or forced by DMA for servicing the DMA routine. So, the block diagram is very simple. This is a DMA module connected to the CPU bus, and it has certain control lines like DMA request to the CPU, and if DMA request is granted, that it knows that DMA is having the charge, and it generates interrupt frequently for the CPU that yes, I need your service, and during that process it will get whether the read operation is to be done or write operation to be done, and it has additional information registers that are used to take care of the volume of data. So, it will have address register. This address register is basically start address. It has a data register which stores temporary data that is being read, and there is a count of data, that is how many bytes to be read from the start address. Okay. So, it will start from this location, store data temporarily here, and transfer it to the CPU bus, and then it will move to the next byte location and read it and send, and that is control using DMA controller control logic. Okay. Now, if you visualize this in more detail with this diagram, we can easily see, and we know in the control unit design that instructions are executed in cycles, and there is a fetch cycle, there is a decode cycle, then there is a fetching of operand, okay, then we execute the instruction, and then finally we store the result. At this point, the interrupt is seen by the CPU, and it knows that yes, DMA require the services of CPU bus for data transfer. Now, after this, okay, for the next instruction, okay, there will be a DMA breakpoints, or there is a forceful cycle stealing by the DMA. So, what will happen at start of the next instruction, there will be a cycle stealing, and when 2 cycles has been performed of the processor cycle like fetch and decode, then there will be a DMA cycle forcefully taken by DMA from the processor, and after fetch of operand and execution of instruction, then there will be a cycle steal for the data transfer, and this will again and again go for subsequent instruction I1, I2, I3 till all the bytes or volumes of data has been transferred. So, basically DMA is doing a task of stealing the CPU cycles for using the bus. So, this is very important thing of DMA, that it works in one by one, okay, first CPU then DMA, first CPU then DMA, one by one they are taking the buses of the CPU to transfer the data from the main memory or IO interface. Since IO interface is somewhat like main memory with this limited address space, and that has to be read for some data to be exchanged with the main memory. So, dear students, we have discussed today very important concept of various modes of IO data transfer. We have discussed the programmed IO, we have discussed the interrupt driven IO, and finally we have discussed the direct memory access, and we have compared all these, and we have discussed what are the advantages and disadvantages of this. Jai Hind, thank you.